Uh, this is the first video in a series of videos describing how to build your own robot from scratch. I'm going to cover everything from code to hardware, motors, machining, motion theory. We're going to cover everything. So basically, a robot means different things to different people. So it could mean a little robot that runs around the house, vacuums, or does some chore, or does nothing but run around the house. Or it can be an industrial robot that maybe an arm or a plasma table or a welding machine. It can be a whole myriad of things, but they all have certain things in common. They have a computer that controls them. They have code that runs in the computer. They have motors. They have sensors. And they're made out of some kind of thing, like some material that has to be machined, molded, formed in some way. So we're going to cover as much of that as we possibly can. So first we need to figure out the concept of what we're building. That's the first thing, concept, and then we build a prototype, and then we keep moving forward until we have a near perfect working machine. Okay, so every robot has some kind of computer, usually a microcontroller. A lot of times it's called an embedded system because it's a small, dedicated computer. All right, so the microcontroller somehow has to take the code. We have code. Code goes into the microcontroller and makes it work. And we're going to use, mostly we're going to use the C. Oops, that don't look too good. We're usually pretty much going to use the C language. Pretty much. Sometimes assembly, but C is pretty good to work with. All right. And then somehow you have to convert that code into some form of motion. So usually, and certainly in our case, we're going to have a different separate board called a motion board. In fact, we're probably going to have more than one. You can have a motion board that controls more than one motor, or you can have a motion board for each motor for each axis. So the microcontroller and the motion board have to communicate back and forth, because the microcontroller is going to send the code that makes the motion into the board, and then the robot has to give feedback in position, speed, velocity, stuff like that. So the motion board controls the motor, one or more motors. Usually each axis has a motor for its own. So the motor is a one-way. You just send power to the motor, usually in the form of a square wave, PWM. Now we're mostly going to use brushless DC motors, called BLDC motors. And the reason we're going to use that mostly is because they last longer, you have a better torque to speed ratio, they're probably going to be lighter, and they run smoother and quieter too. Okay, so the motor The motor's got a shaft and it's turned some gear mechanisms, but also you got to have feedback. So the feedback can come in two ways. The feedback can be from the motion board reading the coils in the motor and determining some position and speed, or you can use an encoder that counts the rotations or the degrees or steps of the motor, and it sends signals back. And through these one or both of these mechanisms, the motion board can determine the speed and the direction of the motor. All right, and it can also stop it and start it and increase it, accelerate and decelerate. The motion board is very busy, and we're probably going to use a DSP chip in our motion board or boards. We'll probably have at least 2 motion boards. Okay, so that's the basic concept. Now, we have to divide it up. We can't do everything at once, so the first thing we need is some kind of microcontroller. So you could use an off-the-shelf one, but I have, in process, I'm developing a microcontroller I call main brain. So the idea of main brain is you have a board, and it's not very big. It's like 2.5 by 3.8 inches. But you have this board, and on it you have a microcontroller chip. All right, MCU. Now, there can be numerous support chips, memory, flash memory, communication. That's all up to you as the designer to figure out what you need and what you want for your application. So, main brain is designed, it has a connector right here. And it's designed for another board, in this case most likely a motion board, to go up on there and plug in underneath, and you can stack, in theory, as many boards as you want, but I mean, you got some issues there we'll talk about later, but I mean, you could stack 2-3 motion boards here very easily. Now, one of the concepts with main brain is there's a static RAM chip right here, SRAM, and it's called a dual port RAM. So the CPU communicates, reads and writes with this SRAM, and it's interfaced to this output port, and this DSP chip here, or whatever kind of microcontroller is on the motion board, can read, write through this connector to the same static RAM at the same time. So that guarantees very fast communication, and that's what you need. You need this microcontroller to take the code that you write and it could be a program that describes movement and direction and then a task that you want your robot to do. So, and it processes your program and sends commands to the motion boards, and there can be another motion board here, and they're connected all through this connector right here, and they can all communicate with this SRAM. Now it gets a little complicated when you got different boards, but this SRAM is going to hold a lot of data and commands, and these can read it as this one's writing it, and it can go. Static RAM is fast, so it can move along pretty fast. So that's the main concept of my main brain microcontroller, and that's going to be in section 1. So we have make your own robot. Okay, that's the main theme. So then it's going to be divided in sections. So section 1 is the MCU, which is, in my case, is main brain. And I'll use that as an example. I'll take you through all the development of it and the building of it and everything I've done so far. So then number 2 would be the motion board. The motion board gets, they're almost the same kind of process, but 2 different types of microcontrollers. Mainbrain's mostly tasked with taking your code and that you write to move the robot in a certain way, and it processes it, sends it out to the motion board. The motion board determines the finer details of how to turn the motor and when to start and stop it and how fast and all that stuff. So the second one will be the motion board. Alright, so then once you get the motion board and the microcontroller developed, then it'll be time to actually build the physical part of the robot. Because in here, we'll be testing, once you hit here, we're going to test some motors and stuff. And then number 3, section 3, will be the physical machine. And that'll involve a lot of like AutoCAD or SolidWorks. I use AutoCAD. A lot of machining. I got a mill and a lathe and a welder outside in the shop, and we'll be going there quite a bit. And so that's pretty much the introduction here. And so next up, we'll start discussing main brain and what it takes to develop the microcontroller part of the robot. So that's it for now. See you on the next one.